Hello, so today we will be doing something about the primal and dual LPP. Always remember this one that given an LPP, you can always have another LPP associated with the given LPP. The given LPP, it's called the primal LPP, and the dual LPP, okay, we have to formulate it based on the primal LPP, that is based on the given LPP. Okay, so if you have to do this one, okay, you just take a look at this example. Okay, it is very easy. I will give the general steps in the notes. Okay, but let us take a look at this example. So if we have to convert it into, if we have to find the dual LPP, okay, why exactly do we need to find the dual LPP? You will see. Okay, sometimes, okay, there are too many constraints. Sometimes there are too many variables. If we can interchange the number of constraints and the number of variables, it will be very helpful. Okay, sometimes plotting all the constraints in a graph, okay, it takes too much time. Okay, but if you have a smaller number of variables and if we can interchange them, again, I repeat, it's very helpful. That is exactly what we will do over here. We will interchange the number of constraints with the number of variables. Okay, but first, how exactly do we do it? You must remember that this primal LPP, it can be either a maximization or a minimization problem. It doesn't matter. Okay, it will the dual LPP will of course change. Okay, do not worry, we will do for a minimization problem later on, but now let us just concentrate with this maximization problem. One of the things that you need to know is that first of all, you have to convert this into equal signs. All the constraints will be equal signs. Okay, that is exactly what we will do. Okay, so solution. Okay, the given LPP can be written as okay, we can leave this one as it is. Even if it's a minimization problem, we can leave it as it is. Doesn't really matter. Okay, we don't need to convert it into a maximization problem. We can just leave it as it is. Okay, subject to. Okay, now over here what we will be having, minus 3x1 plus x2. We can introduce, this one is x1. We can introduce slack or surplus variables depending upon the question. Okay, 3x1 plus x2 plus s1 is less than or equal to 1. Okay, and over here, because we are having three variables, it is best if you also write it as plus 0x3 plus 1s1. Okay, you will see why. Similarly, this as constraint can be written as x1 minus x2 plus x3. It doesn't have x1, does not have s1, so you can write it as 0s1. But you will also have to introduce another variable over here, which is s2. Okay, so what we can do, this one will be plus 0s2 equal to 1, and over here will be 1s2 equal to 2. So we have converted this one into equal signs. And also the objective function will also change. We will also have to incorporate s1 and s2, which we can easily write as 0s1 plus 0s2. Okay, x1, x2, s1, s2, they are all greater or equal to 0. Okay, so once you have changed this one into equal signs, and once you have written the constraints with all the variables x1, x2, x3, s1, s2, similarly for all the constraints, now we just need to find the dual LPP. Okay, the dual LPP is, okay, because the given question, the primal LPP, which is the given question, is in terms of maximization, so the dual LPP will be in terms of a minimization problem. Okay, we can write it as minimize z star. Okay, how exactly are we going to do it? You just see that over here we are having only two constraints. Okay, so over here in the objective function, now we will be having only two variables, which is w1 and w2. Okay, again I repeat, how do I know that there will be two variables over here? Because there are only two constraints here, and over here there's 1 and 2. So similarly over here will be 1 plus 2. If it is minus minus, similarly you can write minus 1 minus 2. Okay, depending upon the sign that you are given in the primal LPP. Okay, so subject to, okay, I forgot the question. Okay, it was 2x1 plus 3x2. Okay, let us see now how are we going to form the constraints. But now if you see, we will be having 5 constraints because we are having 5 variables. Okay, the two variables have changed, the two constraints that we are having in the primal LPP, it has changed into 2 variables, whereas the 5 variables that we are having will be changed into 5 constraints. How exactly are we going to do it? Okay, it's just like this. Okay, so all the constraints now we have to write it in terms of w1 and w2. It's very easy, just take this one, minus 3 w1 plus w2. Because the original problem is a maximization problem, so the constraint will all have to be greater or equal. If it is minimization, then over here will be less than or equal. Okay, it's very simple. Okay, but over here, what will be the number over here? Will be this 2. Okay, 2, it is corresponding to x1, so that's why it will be greater or equal to 2. Similarly, over here we'll be having for x2. But now we will write it in terms w1, w2, 1 w1 minus 1 w2. It will be greater or equal to 3. Okay, similarly over here, 0 w1 plus 1 w2 greater or equal to minus 1. Okay, similarly over here, 1 w1, 0 w2 will be greater or equal to 0. Okay, so you can just write it as w1 greater or equal to 0. Similarly, the last one will be 0 w1 plus 1 w2. It will be greater or equal to 0. Okay, so this is all. Okay, we have got the objective function, and also we have got the constraints. Now all that we need to do is remember that w1 and w2 are always unrestricted in sign. Restricted in sign. Okay, they can either be positive or negative. Okay, so this is how we form the dual LPP. Just remember that first you need to convert constraints into equalities and then just do the steps accordingly. And w1 and w2, they are now called as the dual variables. Okay, w1 and w2 are the dual variables. Okay, so this is how we do it. Okay, so if you see the original LPP, it cannot be solved by using graphical method. Okay, because we had 3 variables. Okay, x1, x2, x3. But this one can easily be solved by using graphical method because now we are having only 2 variables. Okay, you will see, okay, why do we do this? Okay, how is the solution of the dual LPP related to the solution of the primal LPP? Okay, you will learn when we are doing some more exercises. Okay, but I tell you, it is really helpful. Okay, so that was an example. Okay, just another quick example from the dual LPP. Okay, I will do it for minimization problem this time. Okay, we can just make it up. 5x1 plus 2x2. Okay, so now we are having only two variables over here, and we will be having, let us say, four constraints. Okay, x1 plus x2 less than or equal to 1, x1 minus x2 less than or equal to 3, okay, x1 plus 5 okay, plus 3, x2 greater or equal to minus 1. Okay, let us have another constraint, maybe 7x1 minus 11x2 greater or equal to minus 3. Okay, x1 and x2, they are all greater or equal to 0. So if we have to form the dual LPP for this one, again we can leave the minimization problem as it is. Okay, but what we will do, we will change all of these into equalities. Okay, so solution, the given LPP can be written as instead of minimization, we can change it into maximization. Maximize z star. Sorry. Okay, we are just writing it the same thing. Okay, we will leave this one as it is first. 2x2. Okay, now let us change this one into equality. x1 plus x2. Okay, just remember that over here we are having four constraints, so there will be 4 extra variables. Okay, over here will be plus 1s1 and will be equal to 1. Okay, I am leaving a space, you will see why. And for this one, it will be 3x1 minus x2. Again, it will be plus, it will be another variable, plus 1s2 equal to 3. Again, I am leaving a space here and here. Okay, you will see why. 5x1 plus 3x2. Now it's greater or equal. Now we have to subtract minus s3 equal minus 1. Similarly, the last one will be 7x1 minus 11x2. Again, minus s4 equal minus 3. Okay, I am leaving some space. And over here we have introduced some other variables. So it will be 0s1 plus 0s2 plus 0s3 plus 0s4. And over here I'm leaving some space. You can just fill it up. 0s2, 0s3 plus 0s4. You can see over here that again I'm writing all the variables in one line. x1, 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 x2, 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 x2. Similarly s1 in one vertical line. 0s1, 0s1, 0s1. Similarly over here 0s2, 0s2, 0s3, 0s3, 0s4, 0s4, and over here minus s4 or minus 1. Okay, and the variables, they are now x1, x2, x1, x2, s1, s2, s3, s4, they are all greater or equal to 0. Okay, so now let us just form the dual LPP. The dual LPP is, because it is minimization, so now we'll change into maximization problem. Maximize z star. How many variables will we be having now? Okay, it is based on the number of constraints. We are having 4 constraints, so we will be having 4 dual variables, w3 and w4. And over here it is 1, 3 minus 1 minus 3, 1, 3, sorry, this one will be minus 1, and over here will be minus 3. Okay, again 4 constraints, they have been transformed into 4 variables. And now the constraint subject to. Okay, everything have to be written in terms of the variables now. 1, 3, 5, 7. 1 w1 plus 3 w2 plus 5 w3 plus 7W4. Okay, this one will be, because it is minimization problem, so it will be less than 1. Sorry, less than 5. Okay, because it is related to x1. 5. Similarly, 1 minus 1 3 and minus 11. 1 minus 1 plus 3 minus 11 less than or equal to 2. Okay, 1 0 0 0. Okay, will give you only w1. w1 less than or equal to 0. Similarly, over here we will be having only 0 w1 plus 1 w2. We will be having only w2 less than or equal to 0. w3 from this line, okay, minus w3 will be less than or equal to 0. Similarly, over here we will be having only minus w4 less than or equal to 0. So ultimately we will be having this one, which is a dual LPP, where w1, w2, w3, w4, they are the dual variables and they are unrestricted in sign. So this is how we form the dual LPP from the primal LPP. Next time.